Welcome back to Brainwaves. In today's episode, we will explore the life and achievements of one of the most influential physicists of the 20th century, Enrico Fermi. Enrico Fermi was an Italian physicist and Nobel laureate who made significant contributions to the field of nuclear physics. Join us as we dive into the fascinating story of this remarkable scientist. In the early life of Enrico Fermi, a budding physicist was born on September 29, 1901, in Rome, Italy. Growing up, Fermi displayed an exceptional aptitude for mathematics and science. He pursued his interest in physics and enrolled at the University of Pisa, where he graduated with a degree in physics in 1922. Fermi's passion and intellect were evident from a young age, foreshadowing the remarkable contributions he would make in the field of nuclear physics. Enrico Fermi made remarkable contributions to the field of nuclear physics. He developed the theory of beta decay, which explained the transformation of one element into another. Fermi also conducted groundbreaking research on neutron interactions, for which he received the Nobel Prize in Physics in 1938. One of his most notable achievements was the successful creation of the first controlled nuclear chain reaction in 1942, known as the Chicago PILE-1. This achievement paved the way for the development of nuclear power and laid the foundation for the atomic bomb. During World War II, Enrico Fermi played a key role in the Manhattan Project, a top-secret government initiative to develop an atomic bomb. Fermi and his team worked tirelessly at the University of Chicago to design and construct a nuclear reactor that could produce weapons-grade plutonium. Their efforts led to the successful construction of the world's first nuclear reactor, Chicago Pile-1, in 1942. This breakthrough paved the way for the subsequent development of the atomic bomb and changed the course of history. Enrico Fermi's journey began on September 29, 1901, when he was born in Rome, Italy. Growing up in the historic city, Fermi was exposed to a rich cultural heritage that would later shape his worldview. From a young age, he displayed a keen interest in science, often conducting experiments in his home laboratory. Fermi's early life in Rome provided a nurturing environment that fueled his passion for understanding the natural world and set the stage for his future scientific accomplishments. Enrico Fermi's thirst for knowledge led him to pursue a rigorous education and embark on an impressive academic journey. After completing his schooling in Rome, Fermi enrolled at the University of Pisa to study physics. There, he excelled in his studies, publishing his first scientific paper at the age of 20. Fermi continued his academic pursuits at the University of Rome, where he earned his doctorate in 1922. His remarkable intellectual abilities and dedication to learning laid a solid foundation for his future groundbreaking contributions to the field of physics. Enrico Fermi's birth in Rome, Italy, had a profound impact on his life and career. The rich history, culture, and scientific advancements of the city influenced his early interests in science and provided a nurturing environment for his intellectual growth. The vibrant scientific community in Rome at the time exposed Fermi to the latest research and allowed him to collaborate with esteemed physicists. His birthplace also shaped his mindset, instilling in him a curiosity about the world and a deep appreciation for scientific exploration. Rome's influence on Enrico Fermi's upbringing and development cannot be overstated. To understand Enrico Fermi's contribution to the development of the first nuclear reactor, it's important to grasp the background of nuclear reactor development. In the early 20th century, scientists began studying the possibility of harnessing the power of the atom for controlled energy production. The discovery of nuclear fission by Otto Hahn and Fritz Strassmann in 1938 provided the foundation for the concept of a nuclear reactor. This led to further research and experimentation by physicists worldwide, including Enrico Fermi, who played a pivotal role in turning this concept into reality. Enrico Fermi's contribution to the development of the first nuclear reactor was groundbreaking. In 1942, Fermi and his team at the University of Chicago successfully created the world's first controlled nuclear chain reaction. They built a structure called the Chicago Pile-1, which consisted of graphite blocks and uranium fuel. Fermi carefully controlled the reaction by adjusting the configuration and materials, allowing for sustained neutrons and energy release. His meticulous calculations and experimental skills were crucial in achieving this milestone in nuclear science. The significance of Chicago Pile-1 cannot be overstated. It was the first human-made nuclear reactor, a groundbreaking achievement that opened up new possibilities in energy production and scientific research. The successful operation of Chicago Pile 1 demonstrated the feasibility of controlled nuclear reactions and laid the foundation for the development of nuclear power plants. The knowledge gained from Fermi's work on Chicago Pile 1 also played a pivotal role in the later development of the atomic bomb, impacting the outcome of World War II and shaping the course of history. The Manhattan Project was a top-secret research program initiated by the United States during World War II. Its primary objective was to develop an atomic bomb before Nazi Germany could acquire such destructive power. The project began in 1939 and involved some of the world's leading physicists, engineers, and scientists. Their efforts were focused on harnessing the energy released by nuclear fission and translating it into a weapon of immense destructive capability. The Manhattan Project marked a turning point in human history, where science, technology, and geopolitics converged to shape the future of warfare and global dynamics. Enrico Fermi played a vital role in the Manhattan Project as one of its key figures. His expertise in nuclear physics and his brilliant scientific mind made him a valuable asset to the project. Fermi was heavily involved in the design and construction of the world's first nuclear reactor, known as the Chicago Pile 1. He led a team of scientists and engineers at the University of Chicago, tirelessly working towards achieving a controlled nuclear chain reaction. Fermi's leadership, meticulous calculations, and experimental skills were instrumental in the success of the project. His contributions to the Manhattan Project laid the foundation for the subsequent development of the atomic bomb. The Manhattan Project had a significant impact on science, warfare, and global history. Its successful development of the atomic bomb shaped the outcome of World War II and marked the dawn of the nuclear age. The devastating power of atomic weapons demonstrated the destructive capabilities of nuclear energy and brought about a new era of geopolitics. The legacy of the Manhattan Project continues to influence discussions on nuclear disarmament, non-proliferation, and the ethical implications of such weapons. Enrico Fermi's involvement in the project showcased his scientific brilliance and contributed to the advancement of nuclear physics. His work on the Manhattan Project solidified his place in history as one of the key figures in the development of the atomic bomb. In 1938, Enrico Fermi was awarded the Nobel Prize in Physics for his groundbreaking work on induced radioactivity. This prestigious honor recognized his exceptional contributions to the field of nuclear physics and solidified his status as one of the most influential scientists of his time. Fermi's discovery of induced radioactivity, which involved bombarding atomic nuclei with neutrons to create new radioactive isotopes, laid the foundation for further advancements in nuclear science. This Nobel Prize marked a significant milestone in Fermi's career and highlighted the significance of his contributions to the scientific community. Enrico Fermi's work on induced radioactivity revolutionized the field of nuclear physics. Through his experiments, Fermi discovered that bombarding atomic nuclei with neutrons could transform stable elements into radioactive ones. This groundbreaking technique, known as neutron irradiation, led to the creation of new isotopes and expanded our understanding of nuclear processes. Fermi's experiments not only confirmed the existence of artificial isotopes, but they also laid the groundwork for the development of nuclear reactors and the harnessing of nuclear energy for peaceful purposes. His work on induced radioactivity showcased his remarkable scientific insights and set the stage for further advancements in the field. Enrico Fermi's Nobel Prize in Physics in 1938 brought him international recognition and demonstrated the significance of his work on induced radioactivity. The Nobel Prize is considered one of the highest honors in the scientific community, and Fermi's award solidified his reputation as a pioneering physicist. The recognition not only elevated Fermi's status but also had a profound impact on the field of nuclear physics. It inspired further research and exploration into the applications of induced radioactivity and laid the foundation for future advancements in nuclear technology. Fermi's Nobel Prize serves as a testament to his remarkable contributions to science and continues to inspire scientists to this day. And that wraps up our exploration of Enrico Fermi's life and contributions. Throughout his career, Fermi left an indelible mark on the world of physics and continues to inspire scientists today. From his early breakthroughs in quantum theory to his pivotal role in the development of the first nuclear reactor and the atomic bomb, Fermi's work reshaped the course of history. His technical brilliance, creativity, and dedication earned him numerous accolades, including the Nobel Prize in Physics. Enrico Fermi's legacy will always be remembered as that of a true scientific pioneer. Thank you for joining us on this journey into the life of Enrico Fermi.